cosine. So I'm going to do cosine of 4x minus 10. Okay, so then I'm going to go to my window, and I'm going to set my window to what I've got on my grid. So I go from negative pi over 2 to positive pi over 2. Negative pi over 2 to positive pi, over 2, and we're going by increments of pi over 8. That's that first increment there. Okay, now on my y, I've kind of adjusted this a bit. So that lowest one I've got labeled there is 17. So I want to be able to see the bottom of my parabola. So I'm going to go lower than 17. I'm going to go, let's just go negative 25. That should be good enough. On my grid, I go up to 14. Oops, 14. And I'm going by increments of 7 on my grid. All right, here comes the moment of truth. All right, I would say that that looks pretty darn accurate. So I'm calling that one good. All right, question number 3. All right, so again, we're labeling our 4 pieces. So my amplitude is 5. My period is 2 pi divided by my b, in this particular case is 2, so I have a period of pi. My phase shift is going to be 5 pi over 12 divided by 2. Okay, so here's my little trick. I can multiply those two values on the bottom. So we've got 5 pi over 24. Ew. Now that's going to be yucky, but it's the way things are in the real world. They're usually not very nice. So we got to the right because there's a minus. We also have a vertical shift. So we got a plus 8. We got 8 units up. Alright, so labeling my axes, I start with pi. So pi, half of pi is pi over 2. Half pi over 2, pi over 4. And I'm going to label my negative direction. Alright, so then I'm going to label my y-axis. Okay, and again, I always want to think about which function I'm drawing. Okay, this time I'm drawing a cotangent function. Okay, now a cotangent function looks like a bunch of John Travoltas. The amplitude of a John Travolta is very hard to see. I'm not going to be able to tell if you're drawing a 5 or a 20. It's the slope of the John Travolta. So the big piece on this one is going to be the plus 8. So I'm just going to say that that is going to be 8. That's where the John Travoltas are going to do their little wiggle. Alright, so we got there. So now here comes the tricky part, my vertical asymptotes. Okay, so we've got a cotangent which starts with a C. So it's going to have its first vertical asymptote first start on the y-axis, but it's got a shift. Okay, so now this is a pretty tricky shift here. We've got one increment being pi over 4, which I like to kind of ignore the pi's for a second and say, okay, well, pi over 4 is like 0.25. Okay, and I'm going to shift it 5/24. Okay, and if I figure out what decimal 5/24 is, uh, 5/24 is 0.2. Okay, so 0.2 is less than 0.25. So I'm going to move my vertical asymptote to the right, but not all the way one full increment, but it's going to be dang close to one full increment. Okay, so there's going to be my first vertical asymptote. And I still am going to label my first one, even though it is a cotangent and I am just drawing John Travolta's. Still, I'm just going to get in that habit. So I'm going to draw every 2 increments. Okay, so now I'm thinking about a cotangent function, and I'm thinking, okay, well, cotangent function, which arm of the John Travolta is up? Okay, it is the reciprocal of the tangent, so the left arm of the cotangent is up. But again, hopefully you noticed, there is a negative. So that is simply going to flip John's arm, and the right arm is going to go up. So the way this is going to look is it's going to be a fairly steep, which is again going to be hard to tell by your drawings versus what the calculator is going to show, but the important pieces there is going to be a wiggle at 8, and the John Travoltas should have their right arms up. So let's throw one over here. And again, let's just double check to make sure that I did do that correctly. So clear that one out. We've got -5, and we've got cotangent, so that's going to be divided by the tangent of 2x minus, and I can just type in 5 pi over 12 in this scenario because the calculator will do order of operations for us. But I do want to make sure I end the parenthesis there. Whoops, 12 and plus 8. Alright, so then I'm going to go into my window and make sure I match what I see here. So I go from -pi to +pi. My increments are pi over 4. Then on my y, I go to -16 to +16. And by increments of 8. Alright, so here comes my moment of truth. And I'd say that looks pretty darn close to what I've drawn. I like it. Alright, so here's the last one that I'm going to do for you guys. Hopefully that this video has been helpful enough. I will link it it is linked on the website. So if you need to slow it down and watch it again, feel free to do that. First thing I'm going to do is kind of erase what I got here so I can see what the function says. Alright, here we go. So amplitude 2, period, 2 pi divided by 8 makes pi over 4. Phase shift, there is no adding or subtracting within the, shift, within the parentheses. So no phase shift. Vertical shift is up 8. Alright, so fourth increment is pi over 4. Half of pi over 4 is pi over 8. Half of pi over 8 is pi over 16. Do that in my negative direction. Alright, my y. So my y, my amplitude is 2. But I have an up movement of 8 units. So I want to make sure that that looks fairly good on my grid. So I'm going to kind of go, I'm going to say this middle line is going to be 8 for me. So then I'm just going to kind of say that up 2 from there is going to be 10, and I'm going to draw a little dotted line. And down 2 from there is going to be 6. Okay, so hopefully it makes sense as to why I just did that. Okay, so remember my amplitude was 2, so think that if I normally started at 2 and moved that up 8 units, 2 plus 8 makes 10, so that's where that 10 came from. The minimum one, if I had the amplitude of 2, would be at -2, and if I move -2 up 8, that hits 6. Okay, so that's where my parabolas are going to minimize and maximize. To draw my vertical asymptote, I have a cosecant with a C, so that means cosecant starts on the first, or excuse me, not on the first, but on the y-axis. So y-axis, and I would shift it, but I have no shifts, so it's going to hold true right on the first, excuse me, I keep calling it the first, the y-axis. Alright, so I'm going to draw 5 of these since I can. Okay, so here we go. So I've got a cosecant function. Okay, remember that the cosecant function, the first parabola is going to start to the right of it. usually. But in our particular case, I hope you noticed, again, we've got a negative, which is going to flip that sucker right upside down. So instead of going up, we're going to have upside down parabola for the first one. So that's my first parabola, and then I just simply alternate. Okay, so I want to make sure that I have 4 parabolas drawn. All right, and I'm going to verify and make sure that I did do that correctly. So I'm going to type that in the calculator. I've got -2 divided by the cosecant, which is the inverse of sine of 8x plus 8. Going to my windows, for my scale, I go from -pi/4 to +pi/4. And I'm going by increments of pi/16. That's the first increment. Pi/16. For my y, now this is a little bit funny. I'm just going to go ahead and, since my middle one was 8, let's just kind of go with that. That works for me. I'm just going to say from -8. That should go down plenty far, and then I need to at least go up to 16, which I have 8, and going by 8s again. Perfect. So I'm going to graph that. See with what I have looks fairly good. And I would say that looks perfect. So there you have the first 4 done. So the rest of this worksheet is your homework. So as I have said, all of these things need to be done for each graph. Okay, you need to identify all 4 pieces, that's step 1. You need to label your axes, that is step 2. And then draw the graphs, that's step 3. Okay, so good luck.